So you try to understand. Similarly, target can be a file or target can be a database, target can be anything. Are you able to visualize this, Amrita?
Yes, yes.
Try to understand. Here we have multiple sources from where we extract data. These all are the sources, right?
Mm-hmm.
So there are multiple heterogeneous sources. Right from the beginning, we are talking the same. And your ultimate target is, I'm saying, data warehouse, right?
Yes.
So data warehouse is also a relational database. Here is your ETL project. This is your whole ETL project, right?
Right.
When you focus on a complete ETL project, ultimately these databases or files, these things are the sources. And data warehouse is the target when you focus on complete project, right? But to do this complete work, we will be developing and executing multiple ETL jobs. Here you do have these staging areas. For example, this is staging area 1, this is staging area 2, this is staging area 3, and so on. This is level by level, step by step processing of data. Do you agree?
Right. So in the staging area, that is where all the cleansing and all things happen to the data, right?
Yes, of course, let you assume that a staging area is also nothing but a database.
Yes.
For example, this is a database that is staging area 1.
Okay.
This is another database. This is staging area 2.
Okay.
This is another database that is staging area 3. Okay.
Okay.
So here we are developing ETL jobs. At the level 1, to extract the data from our ultimate sources. Ultimate sources are operational sources, external sources. Those are the business databases, right?
Right.
So here each box represents one ETL job, Amrita. Either you call it as a ETL job or ETL task, whatever it is. So these all green color boxes are ETL jobs, right? Level 1 ETL jobs. Okay.
Right.
So these ETL jobs are intended to extract something from the source database, perform some transformations, and load data into your staging area 1. Okay.
Okay.
Similarly, job 2 is also do something like that. Each job performs extraction, transformation, and loading, right?
Right.
This is level 1. Okay. This much are you clear?
Yes.
So now after level 1, where is your data? Your data is in staging area 1, right?
Yes.
So you will develop some more jobs to extract the data from staging area 1 and load the data into staging area 2. Okay.
Right.
So here level 2. At level 2 you might have multiple ETL jobs. These ETL jobs are intended for extracting data from staging area 1 and load the data into staging area 2. Similarly, after staging area 2, you will have multiple jobs. So that is extracting data from staging area 2 and load the data into staging area 3. After that, we'll have multiple jobs extracting data from staging area 3 and load the data into data warehouse, right?
Right.
Do you understand this much?
Yes, yes.
Now you see, for this job, let me concentrate on this particular job. For this job, what is source? Source is this one. What is target? Target is this one. Here you perform the transformations. Got it?
Yes.
So for each ETL task, source will be there, as well target also will be there. So source can be anything. It can be a database table, or it can be a file, or target can be anything. It can be a database table, or it can be a file, right?
Right.
So when you are talking at the task level, at the ETL job level, source can be anything, target can be anything. But when you are talking whole project level, then the source is your operational source, your transactional databases and files are the sources, target is your data warehouse. When you focus on complete project, understand?
Okay.
So this you should be understand, this you should be very much clear. That's what is source, what is target. So when you concentrate like this, you can say target may or may not exist. If the target is already exist, you will be loading data into existing target. If the target is not already exist, you will be create the target and load the data into the newly created target, right?
Mm-hmm. Yes.
This is what is source, what is target. So as per this diagram, these are the sources, data warehouse is the target, at the middle you have staging area, right? Already you understand how the staging areas are level by level processes. Then you have to understand what is staging area, okay? Staging area is a system that can be a database system, that can be a file system, whatever it is. Staging area is a system that stands between the legacy systems and analytical systems. Legacy systems are nothing but your source systems. Analytical system is nothing but your data warehouse. The staging area stands between your source and target systems, right?
Right.
So staging area can be considered as back room of the data warehouse. Staging area is the ETL playground. Okay, the ETL developer can use staging area as he needed. Comfortably, flexibly, he can use whatever he want to do. He can do at the staging area. So all the transformations, all the mid-level data processing logics can be executed by using staging area, right?
Right. Okay.
So staging area is considered as back room of the data warehouse. So staging area is the location where extraction, transformation, and loading takes place. Got it?
Got it.
Are you clear?
Yes.
But do not confuse. Staging area can be a database. Staging area can be a file. This you understand, right?
Yes.
But what is your ETL job? Your ETL job is a program, right?
Okay.
Your ETL job is a program. Your ETL job is your extraction, transformation, and loading logic, right?
Right.
So this program utilizing the staging area, extracting the data. Utilizing staging area, transforming the data. Utilizing staging area, loading the data, right?
Right.
So please do not consider ETL operation done by staging area. That is wrong. ETL operations are done at the staging area, right?
Right. Right.
Understand? So
Yes.
this job utilizes staging area, utilizes that memory. The ETL job is a program. Understand?
Yes.
So data So here the data staging area is the where extraction, transformation and loading takes place. Got it? So staging area can be logical or physical. As per this diagram I am showing you, so here I say these are the databases. So these staging areas I do consider as physical, right? Do you agree?
Yes.
What happened my system? 1 second. Okay. So these staging areas are physical, but a program can utilize a staging area that is a buffer. To run a program, we need buffer or not? Some temporary memory. It occupies some temporary memory, some buffer memory, right?
Right.
That buffer also considered as a staging area. Understand?
Okay.
Yeah. So Amrita, for better understanding about staging area, I will tell you a live example. So regularly we do cook rice and curries, these things, right?
Right.
You are from South India or North India?
North India.
So roti.
No, no rice.
Rice, okay. From where we will get the rice?
We can
Of course, from the
get
supermarket.
yeah, grocery store and then cook, yes.
As we know, it is from the supermarket. Behind the supermarket, there is a lot of story. But we know we are getting rice from the supermarket, right?
Yes.
Rice, dal, and other groceries. Okay. From where you are getting vegetables? Fruit market, this vegetable market.
Yes.
So supermarket and vegetable market, these both are sources for us, right?
Right.
To carry rice and other groceries, to carry vegetables, we use some kind of carry bags or not?
Yes.
These carry bags are like a buffer, okay?
Okay.
And after getting those items into house, where do we keep it? You will keep it in some bowls, right? Baskets, right? Okay, fine. Then when you want to cook food, cook a curry, you will use several bubbles or not? Bubble 1 to clean them, okay?
Okay.
Bubble 2 to cut the vegetables and keep the things after cutting, right?
Right.
Bubble 3 to put on the stove. Bubble 4, keep the curry ready, right?
Right.
So what is this bubble 1, bubble 2, bubble 3, bubble 4? These are the staging areas, right? You are not going to keep the item permanently in the staging area. Temporarily, to process it, some base is required. So you are utilizing the bubble, right?
Right.
Bubble is not cooking the curry. Stove is cooking the curry, right? The heat generated by the stove and automatically the process happens. But bubble is only the base. You are utilizing the bubble. Similarly, staging area is memory. Staging area can be a file. Staging area can be a database. Staging area can be a buffer memory, temporary memory. So that I am saying here, staging area can be logical or physical. So these all operations, extraction, transformation, loading, these all are done at staging area by utilizing staging area memory. Understand?
Okay.
Yeah, this is what staging area is. So what are the functions done at staging area? extracting data from multiple legacy systems. So multiple legacy systems means each system behavior is different, Amrita.
Okay.
Suppose your staging area, your source is a database table, okay?
Mm-hmm.
How can you extract data from database table? By writing an SQL query, by executing an SQL query?
Okay.
So what is happening here? You are sending an SQL statement, SQL query to the database engine. Database engine will process the SQL query and gives you the data. That data you are taking. That's what an extraction, right?
Yes.
But in case data is in file, in case data is in a file is not having any capability of processing some queries or processing some statements, right?
Yes.
So we have to go with file processing. Open the file, read line by line. Got it? This is what extracting from a file. The difference is something like, for example, you have pen with you, Amrita. Okay?
Mm-hmm.
I want to take pen. What I will do? I will request you, Amrita, please give me your pen, right?
Right.
You are giving so that I am taking. This is one kind of process, okay? In case pen is on table, okay? Somewhere on the table in the pen stand, okay? So if I ask table, give me the pen, table will give you. Definitely no, right? You have to take the pen from the table. Do you agree?
Okay. Yes.
The difference between I'm requesting you and I'm taking pen from the table, right?
Right.
Same difference is applicable here also. You are sending an SQL request to the database engine. Database engine is giving you data that you are taking. That's what extracting data from a relational table. But in case of file is not giving you voluntarily. You have to open the file and read line by line from the file, right?
Right.
So actually this is done by a program that is the source process of your ETL job, but extraction done at staging area. This is one of the functionality of the staging area, right?
Right.
So once the data is extracted, already we are telling right from the beginning, we have data from so many years in the multiple heterogeneous sources. So they may not be very cleaned manner, right?
Okay.
And one more thing you have to understand, what is the meaning of cleaned data, okay?
Mm-hmm.
Doubt is already that is in a database, it was used in our business process, right?
Right.
So it is in a proper structure, but still I am saying it is not a cleaned data. What does it mean? Here my purpose is entirely different. I want to use the data for analysis purpose. The data is not available in single source. The data is available in multiple sources. Whenever I am taking data from multiple sources, altogether may not fit or altogether may not be in the cleaned manner, right?
Right.
Do you agree?
Yes.
Let you realize yourself in the fifth class, in the fifth standard, how do you maintain your notes, class notes or running notes? In the 10th standard, how do you maintain your notes? Right now, in the current state, how do you maintain your notes? Your maturity levels are increased and your dignity in the maintaining the notes is increased and neatness in the maintaining the notes is increased. Lot of changes are came over a period, right?
Right.
But this all content I want to put together, I have to clean it, right?
Right.
The best example, address. Sometime we will write address separating with commas. Sometimes we doesn't use commas, we just maintain spaces, right? So format of the address is different in different cases. Altogether, I want to put in a standard format. I have to clean it or not. Even you know very well, some location, sometimes we'll write door number, sometimes we'll write house number, sometimes we'll write flat number, sometimes we'll write plot number, right?
Yes.
So these all things is something like Confucius and something like garbage altogether when you want to put together, right?
Right.
And you see, I say Charminar, India. State is missing, city is missing. Do you understand? But in India, Charminar is available at only one place, that is Hyderabad. But actually, it is not available in the data. State name is missing, city name is missing, street name is missing. But you can make it, right?
Right.
Whenever you want to get all the address into universal format, right? Yeah. So like this, you have to clean the data. This is address standardization. There's one process in data cleansing, Amrita. So like this, you have to clean the data. Once the data is extracted, you have to clean the data. This data cleaning operation is also done at staging area, right?
Right.
And as well, you have to adjust the data like gender, marital status, currency values, these kind of things you have to adjust the data, right? Because whenever you say gender, in every location we doesn't follow the standard format. Sometimes we'll write complete spelling, male, female. Sometimes we'll write MF. Sometimes we'll maintain like S, no, right? Altogether, I want to put in a single standard data warehouse format. I have to convert the data. I have to adjust the data or not.
Right.
Similarly, marital status. Sometimes we'll write married, unmarried, married, single, couple, single, like this. So these all things we want to put into single standard format. So we have to adjust the data. Simply currency conversions also, right? That is data adjustment process. So transforming disparate codes for gender, marital status, etc. into data warehousing standards, right? So data must be cleaned, data must be adjusted. Then the data coming from multiple heterogeneous sources, we have to combine together, we have to put together. That is what integrating data from multiple systems into single data warehouse, right?
Right.
That is data integration. And moreover, I am telling you, data warehouse contains analytical data, not the transactional data. What is analytical data? It is summarized data, consolidated data, right? So we have to aggregate, we have to prepare the summarization, right? Summary values, aggregating the data. And as well, you know primary key, foreign key relationships, Amrita, in the database?
Yes.
How do you maintain primary key, foreign key relationships in the transactional database is different. Those are the source systems. But how do you maintain the primary key, foreign key relationships in the data warehouse is different. In data warehouse, we maintain primary keys in the table. Those primary keys are known as surrogate keys, right? So you have to convert your source system key columns into data warehouse key columns, right? That is surrogate keys. So transforming the legacy system keys into data warehouse keys is also one of the process, right? Finally, loading data into your destination database, data warehouse. These all functions, these all operations are actually done at staging area, okay? Now, after understanding this much, do you believe without staging area, just taking data from the source and directly loading data into target, can we make it sense?
Mm,
So can you imagine the situation without staging area?
no, you have to have, that is an integral process of the whole
Yes,
process.
staging area is very important. Why staging area is needed? To improve the performance of data warehouse, staging area is needed. If you want to integrate data from multiple sources, staging area is needed. If you want to perform data cleansing, so for cleansing erroneous data, accidentally miscoded data, deliberately disordered data, so you want to perform data cleaning, staging area is needed, right?
Mm-hmm.
Okay, so if you want to perform data adjustments like gender, marital status, and converting the multiple currencies into standard common value, performing the data aggregation, for this all things staging area is needed. Without staging area, we may not be able to perform them comfortably, right?
Right.
So here the situation is seems like from the supermarket you got the groceries, from the vegetable market you got the vegetables. Directly I want curry.
Mm,
Will it come?
no.
See, you went to hotel, okay?
Yes.
You ordered for roti.
Right.
So here something, what do you say in English? And something I'm confused. Something all the mixture item is will be there, right?
Right.
That should be pressed and made as a roti, and that should be put on the stove, that should be heated, then only roti will come.
Right.
Yeah, the mixture is available. Now you want immediately roti. Okay, the person is taken your order. He said, please wait. What you are doing? Already mixture is there. Give me roti. From where roti will come? They have to make it, right? The process they have to follow, right?
Mm-hmm.
So without that staging area, process cannot be done. So that ultimate target we cannot make. So staging area is very important. We cannot imagine without staging area. Without staging area, the process cannot be performed properly, right?
Right.
That is the importance of the staging area. So what are the processes at staging area? Data acquisition process done at staging area. Data cleansing process done at staging area. Data adjustment process done at staging area. Data integration process done at staging area. Data aggregation process done at staging area. Finally, data loading into the target, data loading process done at staging area, right? This is what actually staging area, Amrita.
Okay.
Do you understand what is source, what is target, what is staging area, what is the importance of the staging area, what are the processes at staging area, right?
Right.
Yeah. Now we try to understand ODS. What is ODS?
The thing which has the recent data, which is 3 months.
Why staging area? Why this ODS? What
I
is the
mean,
necessity of having ODS?
if you, uh, it holds the recent data, right? It is not just the current,
Yes,
you want
so
to,
use of that recent data.
uh, maybe to see a trend for the recent, like sometimes maybe we need to
So
analyze.
basically, business intelligence systems are for management decisions, for the support of management decisions, that you understand, right?
Yes.
So already you know we have different levels of management, like top level management, mid level management, low level management, okay?
Right.
I'm not saying you are a CEO of the company. You are not top level management. Okay.
Mm-hmm.
I'm not saying you are a sales manager or something like finance manager, not like that. Okay.
Mm.
You are not a regional manager, something like that. You are just a branch manager. Okay.
Right.
Suppose your business is bank, you are just manager of one bank. Okay, you are a branch manager.
Mm.
Your responsibilities are not really more. Your responsibilities are more responsibilities are relevant to the operations. Got it?
Right.
You are responsible to take operational decisions, perform the operations effectively, accurately, right?
Mm.
Smoothly, right?
Mm-hmm.
Resolving the operational issues, improvement, making improvement in the operational process. This is what your scope is, your analysis scope is, right?
Right.
A simple example, you are a branch manager. Under your branch coverage, there are 50 ATM centers. So as a branch manager, it is your responsibility to take a decision how much currency must be inserted in each ATM center to perform operations on daily basis smoothly, right? Effectively, to provide the best customer service, right?
Right.
So it's not a common figure. Do you agree?
Right.
Every ATM center, how much currency you have to insert, it is not a common figure. The ATM center which is located in some shopping center, that usage is more. The ATM center which is located in IT offices, that location ATM center usage is more. The ATM center which is located far away from the city, usage is less, right?
Yes.
Some ATM centers usage is more in weekends. Some ATM centers usage is more in weekdays. Some ATM centers usage is more in the beginning of the month. Some ATM centers usage is more at end of the month. Like this, depends on the locality and it depends on the people interest over there. The usage is different. Accordingly, you have to insert different volumes of the currency in each ATM center, right?
Mm-hmm.
So how much currency must be inserted in each ATM center among these 50 ATMs? Taking decision is yours responsibility. Okay?
Mm-hmm.
So now you are not taking any kind of enterprise level decision, you are taking an operational decision, right?
Yes.
To take this decision, how much information is required? You don't want 10 years information, 5 years information, 3 years information like that, right?
Yes. You need recent. That's what.
You want something like since 3 months how the ATM operations are, since 4 months how the ATM operations are. Based on that you can take a decision. Depends on the usage, recent usage, right?
Yes.
So this is not an enterprise level decision, this is an operational decision. So this ODS contains recent data, that is 1 to 3 months worth of transactional history that is useful for operational decisions. Okay. So just try to understand. Typically, an ODS is a normalized structure, right? Why does I say it is a normalized structure? The ODS and OLTP is looks similar in the table structures wise. Because OLTP contains transactional data, ODS also contains transactional data, right? Operational data, right?
Mm-hmm.
So, but only OLTP contains only current data. ODS contains recent history of the transactions. You understand? 1 to 3 months history of the transactions. So, ODS also contains almost transactional data that integrates data based on subject areas. Okay.
Okay.
1 to 3 months historical data, but data warehouse contains years of historical data.
Yes. Like
Yeah,
20 years, 10, like 10 years. How far do we store? How? What is the
how much data you have.
yeah, how much? Generally, how much do you store?
Years data also we do store.
Okay.
So more means as per the projects I dealt with, it's not more than 20 years data.
Not more than 20. Okay.
Because when the computerization is started, when the world started using the computers, not more than 20, 30 years, right?
Yeah, that's true.
So all the organization mostly contains below 20 years data only. Okay. So over a
And so
period,
basically what happens is depending on if all the historical data is in one house, and when depending on the reports you want, you extract suppose like you want just 6 years of historical data, so you will just extract 6 years. So the report is basically customized, right? That's what happens, right?
actually we consider all the requirements from the customer, business intelligence needs, analytical needs of the customer. So depends on his requirement, how much volume of data is required. Is it available with the customer transactional database? So based on that analysis, we take a decision. Even customer says to us, I don't want to analyze everything. So my analysis is totally based on last 10 years. Before that, what happens? Let it go to hell. I don't mind. Like that customer tells us.
Okay.
Depends on the need, depends on the requirement, and depends on the availability of the data only. We consider how much data should be stored, how much data should be extracted and loaded into data warehouse, how much is clean, right?
Okay.
If there is no such requirement, if there is no such limitation, I do say complete business data put in the data warehouse.
Okay.
Okay, whatever data, maybe customer is having 40 years data, 40 years transactional data. I do say that, yes, pull all the data and put it in the data warehouse. Because there is no restriction. Customer may want everything at any point of time, right? This is not a transactional project we are developing, Amrita. Here we are developing a project for business intelligence solution, right?
Right.
So these business intelligence solutions are mostly not requirements driven. They are data driven. Understand?
Right.
Customer might be give us the requirements like his regular process, what analysis he will do, something like that. Here sometimes ad hoc needs also will come. Okay, so business manager, the top level manager suddenly got a new idea, innovative idea. He will come to office and I want this report, different report. It is not a traditional report, right?
Yeah.
Because he got a new idea. For that kind of ideas also, our database must be able to provide the data. Got it?
Got it.
Our database should have the capability. So we are not just fulfilling the requirement of the customer, we are estimating what kind of needs may come. We don't know what ideas he will get in the future, right? So for that also maximum possibility, all the data in the analytical form, we try to make it available inside the data warehouse. That's why data warehouse contains years of historical data, limitless. Okay.
Okay.
Hello, sir.
Hi, Pawan.
Sorry, ఇప్పుడు connect sir Wi-Fi ki. Sorry, sir. Just now I reached home, sir. Yeah.
Almost we are at the end.
Sorry, sir. Just now I reached home, sir, from airport.
No problem. I am recording and I will.
Yeah, okay, sir. Yeah. Thank you, sir.
Now, Amrita, you understand what is ODS. ODS contains transactional data only. ODS contains copy of the transactional data, but ODS contains recent data, 3 months historical data or something like that. This is what ODS is. Depends on the way you are implementing the ODS, depends on the frequency, how you are loading data into ODS. ODS can be classified into 3 types. Okay, Amrita. Hello, Amrita, can you hear me?
Yes, yes.
So here I do say this is OLTP database, current operational database, right? This is OLTP. Okay. This is ODS. This is ODS. So ODS is a different system apart from your transactional database. You understand and you agree with this, right?
Right.
This is OLTP. This is ODS. Since it is not a OLTP database, it is a separate database apart from OLTP, definitely there should be some process to extract data from OLTP and load the data into ODS or not?
Yes.
We have to extract data from OLTP database, transform the data and load the data into ODS or not?
Mm-hmm.
So this process must be executed at any point of time, some point of time, right?
Yes.
So how you are executing, how frequently you are executing this process, how frequently you are updating data into ODS, updating your transactional data into ODS. So based upon that, we will be classifying your ODS into three types. One is class 1 ODS, right? Class 1 ODS, class 2 ODS, class 3 ODS. What is class 1 ODS? As per class 1 ODS, the transaction will be immediately updated to ODS. Transaction 1 is done. That is reflected in OLTP. Immediately that is updated to ODS. Okay? Transaction 2, immediately that is updated to ODS. Transaction 3, immediately that is updated to ODS. Transaction 4, immediately that is updated to ODS. Transaction 5, immediately that is updated to ODS. Each and every transaction, as soon it is performed in OLTP, immediately it is updated, reflected into ODS within seconds. That is class 1 ODS. See here, in the class 1 ODS environment, the updates to the source system are reflected into ODS in just a few seconds. It's almost like a live. Okay? Understand, Amrita?
Yes.
But class 2 ODS is different. Generally, every business organization you consider, the business hours are morning 8 o'clock to evening 8 o'clock, something like that. Okay? Let us consider business hours are morning 8 to evening 8. So in a day, multiple times I will update ODS on a standard frequency for each hour every hour once, every 2 hours once, otherwise every 3 hours once, something like that. Okay? So keep on transactions are going on with your OLTP. Keep on transactions are done entire day. But I decided for every 3 hours once the ODS must be get updated with the latest data. Okay? So morning 8 o'clock, 3 hours means 11 o'clock, right? At 11 o'clock, we will execute this ETL process so that all the transactions up to the 11 o'clock will be updated to ODS. After that, at 2 p.m., again we'll execute this process. So until the 2 p.m. what our transactions are done, they will be updated to ODS. After that, at 5 p.m., once again we'll execute this ETL process. So until 5 p.m. what all transactions are done, those all data will be updated to ODS. Finally, at closing hours after 8 o'clock, once again we'll execute it. So until 8 o'clock, what all transactions are done, they will be updated to ODS. So on a standard interval, for every 1 to 3 hours once, we will execute the process to update data from OLTP to ODS. This is what known as class 2 ODS. So class 2 ODS is updated intraday for every 1 to 3 hours once. So multiple times in a day on a standard interval. Okay? Do you understand what is class 1 ODS? What is class 2 ODS? Amrita.
Yes.
Then what is class 3 ODS? We are not updating ODS multiple times in a day, only once a day, mostly at closing hours. Class 3 ODS usually updated once a day. This is what class 3 ODS. I think you understand classification of the ODS. Why these classifications, right?
Right.
So which type of ODS to implement? Which is the best one? So nothing like that. So it depends on the customer requirement, what latestness of the data he is expecting. Based upon that, we will decide which method, which frequency is good for him, okay, for his analysis. Okay, this is about ODS. What is ODS? In this document, you have OLTP, ODS, data warehouse comparison tables. Okay, so what is OLTP? So audience, who works with OLTP? Operational personnel, right? Who works with ODS? Analysts. Who works with the data warehouse? Managers and analysts. What is the data access? In OLTP, individual records and transactions driven. In ODS, individual records, transactions driven, and also analysis driven. Data warehouse is set of records, it is analysis driven. Data content, OLTP contains current real-time data. ODS contains current and nearer current data. Data warehouse contains historical data. OLTP contains detailed structures. ODS contains detailed structures and lightly summarized. But data warehouse contains detailed and summarized, right?
Mm-hmm.
How do you organize the data? OLTP is organizing the data, depends on the business functions, business transactions. ODS organizes the data based on business subject areas. Data warehouse also organizes the data in subject oriented. What type of data? In OLTP you will have homogeneous data. ODS also you will have homogeneous data. Data warehouse contains vast supply of very heterogeneous data, right? The OLTP does not allow redundancy. ODS allow little redundancy. Data warehouse allows managed redundancy. Because ODS and data warehouse contains historical data, right?
Yes.
In OLTP, you will be accessing the data, you will updating the data that is field by field. In ODS also, you are accessing and updating field by field. But data warehouse controlled batch. OLTP size is moderate, ODS size is also moderate, but data warehouse size is large to very large. Okay. OLTP systems are requirement driven, they are highly structured. ODS is data driven, that is somewhat evolutionary, but data warehouse is data driven, that is highly evolutionary. What is the philosophy behind OLTP? OLTP to support day-to-day operations. What is the philosophy behind ODS? ODS to support day-to-day decisions, operational activities. So to support operational decisions. Data warehouse is for the support of managing enterprise, for the support of management level decisions. This is what comparison with OLTP, ODS and data warehouse. Okay?
Will we be getting this document?
Just a moment. Yeah. I'm sharing a link with you in the chat box. I'm not able to chat with you, I guess.
What do I need to do?
Just a second, just a second. I think there is something wrong from my end. Be available in the meeting. I'll be connect again. Okay?
Okay.